Hi everyone, welcome to week 4 of your Math for the Medical Environment course. This week we are covering section 5. Section 5 has only 2 units in it, Unit 20 and Unit 21, so it should be fairly smooth week for you. As we begin this week, we're going to start with Unit 20, which is all about ratios, and then Unit 21 is about proportions. So let's talk a little bit about what exactly a ratio is. A ratio is simply a comparison of two quantities. So it's a little bit different. Most of us, when we think of a ratio, we immediately go to the idea that it's a fraction, and it can be expressed as a fraction, but it's not the same as a fraction. A fraction is when we think of a fraction, it's more of a part out of a whole, whereas a ratio is just a comparison between two things. So you're going to see ratios written in a couple of different ways. We might use the colon in between the two terms, and then you use the word 2. That's what the colon represents. So say it's 5 to 2, so it would be 5:2. Then we also can write it as a fraction, so 5/2. But the key here with ratios is that typically they have some sort of a label associated with them. So we want to know what are these 5 parts or 5 pieces of what compared to 2 pieces of what. So keep that in your mind as you go through this week. So this is an example. A supply cabinet contains 24 tubes of antifungal ointment and 60 tubes of antibiotic ointment. So they want to know what's the ratio of antibiotic to antifungal. So when they say antibiotic to antifungal, what that means is the antibiotic is going to come first and the antifungal comes second. So you have to make sure you do them in the correct order. So that's going to be 60 tubes of antibiotic to 24 tubes of antifungal. And I urge you to make sure that you write your units of measure down with them. Now, they didn't do that in this example from the textbook company, but it really will make things much, much simpler in the next unit if you're writing down units of measure when you're looking at the ratios. So then the next slide goes on to show you, well, what do you do to express it in lowest terms? So because both the 60 and the 24 can be divided by 12, we can reduce that to 5 to 2. So that's where they're coming up with the 5 to 2. They're simply reducing that ratio. Okay, so here's another practical problem. We've got a label on a gallon of ice cream. It shows the total fat content as 12 grams, and 8 grams of that is saturated fat. So what is the ratio of saturated fat to total fat? So again, make sure you take saturated fat first, which is 8 grams, over the total, which is 12. So it's going to be 8 to 12. And then we want to reduce that. So it's 2 to 3. So the ratio is 2 grams of saturated fat to every 3 grams of total fat. So again, it's key to make sure that you identify those units. That's going to be very helpful in this next unit. The next unit is all about proportion. So what a proportion is taking two ratios that are equal to each other and writing an equation. So an equation that states the two ratios are equal is what a proportion is. And then we solve that proportion by using cross multiplication. So they talk to you a little bit about the basic principles of proportion. We call the first and last numbers the extremes, the two middle numbers the means. And if it is a true proportion, in other words, if it's equal, those means are going to equal the extremes. The product of the means are going to equal the extremes. All that's saying is you can cross multiply. Okay, so cross multiplication is how we solve, and they're going to give you a couple of examples here. So here's an example. We have how many grams of boric acid are needed to prepare 500 milliliters of a 5% solution. Now 5% means 5 per 100. That means there's 5 grams in every 100 mils of solution. So we can use that to solve a proportion. We want to know how many grams are in 500 mils. We know because it's 5% that there's 5 grams in 100 mils. They went ahead and reduced that 5 over 100 to 1 to 20. If you do that, that's fine. If you don't, you're still going to get the same answer. So whether you use 5 over 100 or 1 over 20, you're still going to get the same answer. So keep that in mind. So they took that information and they wrote a proportion. The question is, how many milligrams are in 500 milliliters? So the first thing we're going to be solving for is how many grams, because these two units must be the same. We know there's 1 gram in 200 milliliters. Cross multiplication of this one is going to give me 25 grams. But the question asked, oh, interesting. They made a typo. I thought that sounded weird. Just so you know, guys, there is a typo. This should say grams and not milligrams. I thought that looked a little strange. So I will get that adjusted on this slide before I upload it for you guys. So you'll see, when you see the uploaded slides, it'll look a little bit different than what you're seeing in the video. So this should say grams. So how many grams out of 500 milliliters when we know there's 1 gram in 20? They did the cross multiplication. So 20x equals 500. And then dividing both sides by 20, you're going to get 25 grams of boric acid. I'd be happy to go over more examples of this with you if you have any questions. I know that was probably a little confusing because of that typo, but please let me know if there's anything I can help you with, and have a great week.